exactly pan out. So this is a bit of a personal rendition of the Armadillo timeline. I started on the team in 2017 as the communications subteam lead. And so my first major checkpoint was the ground operationist readiness review in February 2018. At that point in time, we had about 20 trained and certified student operators via our training process, and we had completed many flight rehearsals that included simulated contacts and anomalies as well as resolutions. We also maintained our ground station by having regular contacts with amateur radio satellites. Then things took a little bit of a turn for the worse. In May 2018, the UT Aerospace Department announced a building move, and then in June 2018, Armadillo's launch was announced to slip to an eventual launch date in June 2019, and unfortunately that meant that all the people that were trained were graduating, and then in 2019, the aerospace building was destroyed. And this was especially bad because our ground station was not established 2 months out from launch. And then it launched. In June 2019, Armadillo was launched on STP-2, a bittersweet moment because, of course, none of our ground station infrastructure was quite in place yet. So immediately after launch, we had some concerns about Armadillo tumbling. It was reaching its momentum limits. The ground station construction was severely limited because it was a summer launch. Many of our students were gone, so we were down to about 5 students part-time, and everything was manual. So that came to make things very challenging. We finally heard from Armadillo from the UT ground station on Apollo 50th anniversary. This was also bittersweet, though, because we discovered that our GDS software could not command Armadillo due to some issues with the implementation of Doppler shift in the flight software. So, of course, we had to try. So we started attempting some patches with the GDS software. Those, unfortunately, were unsuccessful. And then we had Georgia Tech do some pings concurrent to our ground station development, and those attempts were also unsuccessful. Then, even with all these issues, the student leadership started having some frustrations, and the ground station eventually suffered a fault that put all of our contact attempts on hold. That meant in 2019 of September, most of the team was then moved to other projects, and it was downsized to about 2, and there were a few attempts, but none were particularly successful. But thankfully, y'all have heard plenty about SatNog so far, but we had a dashboard built shortly after launch, and it monitored Armadillo's health and kept my hope alive, and so Armadillo then survived for 3 years. So what was the core issue with Armadillo Command? Well, the GDS software directly controlled the radio, and this was software built by a student that had long since graduated and completely from scratch as a master's thesis. So this was extremely difficult to sort through. It didn't allow us to pipe packets to different files or ports, and that meant that we either, to implement this Doppler fix, we either had to fix that software or completely rewrite it from scratch. There was also a severe lack of understanding in terms of the actual command implementation, as I'll briefly cover. It's using Google Protobuf, so it's not exactly standard. And Armadillo didn't help things either with unreliable communication with it continually tumbling and GDS faults. So in January of 2021, I started my master's at Georgia Tech and started working with the ground station network there on a couple other recovery attempts. And I spent my time to rebuild the Armadillo GDS software. Part of this attempt was rebuilding the command dictionary because there was a lack of file transfer between institutions. So I had to rebuild that, and then I also discovered that Armadillo's packets for onboard had an onboard execution time even for acknowledgements. And a very critical component of that is that the commands with execution times in the past are automatically dumped. So that'll take us into the GT ping attempts that were concurrent to the ground station efforts at UT. The pings were attempted by recording the output of the entire GDS chain, and then that packet was then transmitted at the appropriate Doppler shifted frequency over a series of months. Due to a misunderstanding of the flight software at this point in time, that effectively meant that it was, even if a packet had survived through that re-recording process, it was still going to command Armadillo to acknowledge it in the past, and so it didn't particularly yield any results. A bit about the Armadillo command packet construction. It's a great case of cybersecurity by obscurity, where even the team didn't know exactly how it worked. So a typical AX25 packet has the header, encryption key, and then it's got an encrypted payload with your opcodes and arguments, whereas Armadillo's is a bit of a black box. So how can we ping the satellite? Well, first, find and compile all those proto files as a part of the original flight software, recompile them into Python-based versions, and then build a command generator that implemented all of that, and then run a series of contacts from the ground station in Georgia Tech. And this was successful. So we received first contact with Armadillo on January 29th of this year, and that's 2.5 years since deployment. So these photos, we've got one with a bad packet at an earlier attempt, and then we've got two with acknowledgements in them. So the first pass in particular, it had 93 packets, 85 were command acknowledgements, and we had several, over the first week, we had several successful acknowledgement passes that were inconsistent due to Armadillo still spinning, but the Georgia Tech ground station failed, putting our attempts on pause. Thankfully, we didn't stop there. We actually started doing some data downlink as well. So this is one of our data downlink passes. We got 1350 individual packets, and we learned very quickly that we can't actually data downlink every pass. This was due to downlinking 3 passes in a row that caused a power reset, and you can read more about that in my paper if you'd like. So that led us to us prioritizing the ADCS deployment data. So a little bit about Armadillo at this very moment. It's very healthy. The battery is full / mostly full. It's chilling at about 16.5 volts. It charges for the system and safe mode, pulls about 30 milliamps, and it charges at about 150 milliamps on average while it's spinning. It's got almost 40 megabytes of onboard health data, courtesy of it being launched 3 years ago. And it's within the healthy temperature range. It's still spinning. This is an issue with our ground station, or this makes things harder for our ground station contacts. But this was a core issue at launch due to what we believe was an original watchdog reset that did not command the ADCS to turn back on. And this is easily resolvable if we just send a set of remote procedures to re-enable the ADCS after expected reboots. The command loss timer on Armadillo reboots every 2 days or so, and that means that our current spacecraft uptime is about 2 weeks of consistent contact. And I think the coolest part about all this is that it's still theoretically capable of doing its original mission. Here are a few of the SEUs it's seen over the years. I'm not going to go super into them. I think that it's pretty interesting, though, that the onboard time, we don't actually know when that changed, but it currently thinks that it is in 2002, and that made the initial contact a little bit more challenging, as we had to accommodate that. But some steps forwards that I'm working on for Armadillo specifically. So the IGRF model expired in 2020, so I need to see what kind of impact that has on the ADCS performance, specifically the momentum dump mode. I'm developing a series of checkout sequences that's upcoming, and hopefully in the fall here, that we'll be able to actually check out Armadillo, as well as I'm working on some updates to the GDS software. I won't go too much into that. For the full system checkout, we downlinked a bunch of data for the ADCS, but I still need to work on getting all that processed, so that's why that's still up there. But we need to re-enable the ADCS, detumble the spacecraft, put it into sun pointing, and then pyrocycle the instruments, specifically worried about the photon because there's a coin cell battery that's been up there that's not monitored. And then a more recent wrench into things. It's been several years since launch, so I've got to work on a relicense with the FCC. Thanks for listening to me about my passion projects.
Good job. This is absolutely fascinating. Go ahead, Andy. You start out, but I got a ton of questions. So. too.
It's his new jacket.
With all the great lessons you learned in this project, what are some of the key mitigations for projects going forward that you would implement?
I mean, I think a large part of this project specifically that caused a lot of the issues is the complete development of the flight software from scratch. I think that, especially at Georgia Tech, we're using F prime, and that kind of modularization solves a lot of problems, especially on the GDS end, where you can not have it connected directly to the radio and you can repipe that elsewhere. So I think that's a huge, huge help.
Go ahead, Tom.
Since the technical part of my question was already asked, so I asked the non-technical part of the question. For somebody in a similar situation, right, so in a student environment, with a very frustrating non-functioning satellite, how do you keep the motivation on this? Because that's very important.
Yeah, I mean, I think that the SatNox dashboard definitely helps. Every couple months, I'd check back in as I worked on other projects, and it kind of just I felt an obligation to the project, just to see it through. Especially since after launch, it appeared to be healthy for all this time. We just it was just a series of technical problems that we had to overcome, and we just didn't have that kind of time. So my motivation there was just to see it through, I suppose.
Digital Sawyer, see that?
Yeah, so this is my hobby. My primary research is lunar flashlight operations and fault management. So this is what I do in my free time. Yeah.
So one quick or last question. How important is it to have the advisor? I know Glenn and what he does, but comment a little bit about not only you talked about perseverance, but the support infrastructure that keeps you going.
Yeah, I mean, I think that it is absolutely critical to have support from your advisor, and I think that he definitely enabled me to do this by letting me do it. I think that typically you focus a lot more on your research, and maybe these other side projects are kind of swept under the rug as you get your head down. But I really appreciate that he just kind of lets me work on these things. So I think that kind of support is very helpful.
Good deal. Hey, thank you very much.